So hello everyone, welcome back to the tree series. In the last video we learned about the basics of trees and we looked into some of the operations which we are able to perform on binary trees like in-order traversal, pre-order traversal and post-order traversal. So in this video we'll be looking into a small problem on binary trees, and it's a very easy problem that's available on Codechef. So the problem says, consider an infinite full binary tree. Each node has two children except the leaf nodes, defined as follows. For a node labeled V, its left child will be labeled 2 into V and its right child will be labeled as 2 into V plus 1. The root is labeled as 1. You are given n queries of form ij. For each query you have to print the length of the shortest path between I and j nodes. So the test cases are given and the output is given. So the problem is very simple. First let's visualize the problem. So this is the binary tree that has been given in the question. So now consider this root node here 1. So as per the question, the root node is labeled as 1 and its right and left child will have the values 2 into the root node and 2 into root node plus 1. So 2 into root node will give us 2 and 2 into root node plus its root plus 1 will give us this. In the same way we are able to obtain all the other nodes, and this will go till infinity. So now the problem is we are given two nodes in this binary tree. Let's assume that 4 and 6 are our two nodes, and we should find the distance between these nodes, that is the number of lines that are present between these two nodes. So in this case the number of lines are 4, right? The highlighted lines become the solution. Now let's derive an approach to solve this problem. So what we can do is, if we are given two nodes, let's say 4 and 6, then the way we are able to solve this problem is, if both the nodes are at the same level, then we can either go back one step in any of those nodes, right? And now we will check if both of them have the same parent, right? If there are three nodes and only if they have a similar parent, that becomes the shortest path, right? If the parent itself is different, if the parent is somewhere in here for both the nodes, let's say like this, then the distance keeps on increasing, right? So only if they have a common parent node, then the distance is minimum. So what we are doing here is, for both the nodes we will be going one step back at a time, and the condition here would be the distance which is further from that node will be reduced first. So if there is a node here and we are asked to find the distance between 4 and 14, then we should reduce 14 first and check if they are on the same level. And now that they are on the same level, we will be reducing 7 again. So that's totally random. Then we will check if they are on the same level. No, right? So we will reduce 4 and then we will check if they are on the same level again. No, then we will check which is greater, 2 or 3. So 3 is greater, again we will reduce 3, we are reaching 1, and then we will reduce 2 and we are reaching 1. So the distance between them would be the number of operations performed. Here it's 1 2 operation 1 2 3 4 and 5. So the distance between these two nodes is 5, and the distance path is from 4 to 2 and 2 to 1, 1 to 3, 3 to 7 and 7 to 14. So that's the way we are able to solve this problem. So now let's take another example. So now let's take this example of 5 and 13. So if you just visualize the problem, we can see that the path will be from 5 to 2 and 2 to 1, and then from 1 to 3 and from 3 to 6 and then from 6 to 13. So there the distance is 5, right? So now we derive a approach for this problem. So first we will compare 5 and 13. Since 13 is greater than 5, we will reduce 13. Now we will compare 5 and 6. Since 6 is greater than 5, we will reduce 6. Now we compare 5 and 3. Since 5 is greater, now we reduce 5. So during each operation we will be dividing it by 2. So that's the operation that we'll be performing. Since this is a binary tree and the values are all binary, since the formula is 2 cross n plus 1 and 2 cross n, so the operation is just by 2. So again we will be comparing 2 and 3. 3 is greater, so we will reduce 3. And then we will be comparing 2 and 1. So now 1 is greater, sorry, 2 is greater, so we are reaching 1, and that's the common point for both the nodes, so the distance is obtained. This number of operations. Now let's take these two nodes 8 and 9. Since they both are on the same subtree, right? 4 is the root, and left child and right child of 4 are 8 and 9 respectively, so there are only two operations needed to reach 4. And now consider this case where the nodes are 7 and 14. So first we will be checking 14 and 7. Since 14 is greater, we will be reducing 14, right? So on reducing 14, we are obtaining 7, and 7 is equal to 7. So just one operation is needed. So that's the approach we'll be using to solve this problem. So now let's write the code for this. So first we will be solving this using Python. Let's copy the test case. So first we are getting the test case, and then we are writing the for loop, and then we are getting the node values. Let's say the node values a and b. Now we are just going to perform the operation if while a is not equal to b, right? If a and b are the same node, then there is no point of checking. Let's consider this case where a and b are 11, so the number of operations will be 0. Only if both the nodes are different, we will be incrementing the operation. So while a is not equal to b becomes the n case. So if a is greater than b, we will be reducing a, right? A by, if b is greater than a, we will be reducing b, right? And this should come in elif since only one of the operations is performed. Now for each operation we will be incrementing a count variable, right? So we will write count plus is equal to 1, and for this we will write count plus is equal to 1. Now we should initialize count, right? So let's initialize count as 0. Now let's try to print our count and check the result. So as you can see, we have obtained the output as 1, 2 and 3, and the output required is 1, 2 and 3. So now let's submit our code. So this is going to take some time since there's a while loop and both the nodes are getting reduced. So let's wait for it. So this is one of the important concepts in trees, where the distance between the two nodes will be the depth of that node and depth of other node to the node that's common to both these nodes, to the first node that's common to both these nodes. So it will be the depth of the root node plus the child or the grandchild, and same for the right side to grandchild or the child. and the solution has been accepted. So this is an important concept related to binary trees. In the next video, we'll be learning further more concepts in binary trees. So that's all for this video. Thank you. If you like this video, do like and share with your friends.